Hi friends, in this video let us look at some properties of electromagnetic waves. Now Maxwell's theory states that accelerated charges radiate electromagnetic waves. What I'm going to discuss now is not exactly the proof of this statement, but it helps you get some intuition about this. Consider an oscillating charge. Oscillating charge is nothing but accelerating charge, okay? Now you know that charge emits field lines, right? So it has some electric field. Since the charge is oscillating, the electric field also oscillates. Now, electric field is oscillating. You know the changing electric field, the changing electric flux gives rise to magnetic field. We have discussed this before. And you also know that since electric field or electric flux is changing, magnetic field or magnetic flux is also changing, right? So, magnetic flux when changes with time, what will it give? It gives electric field, right? So, changing electric field is giving magnetic field, and changing magnetic field in turn gives electric field. And again, the changing electric field regenerates magnetic field. Hence, in this way, they both regenerate each other. Are you getting me? And this is the principle of electromagnetic wave. You know that electromagnetic wave is a combination of electric field and magnetic field, right? Time varying electric field and magnetic field. And they actually regenerate each other as the wave propagates through the space, okay? Now frequency of the electromagnetic wave will obviously be the frequency of oscillation, this oscillation of charge, okay? Energy of this electromagnetic wave comes at the expense of the source of accelerated charge. Hope everything is clear till now. What is special about this electromagnetic waves is that they can transfer energy from one place to other over long distances. They can transmit energy as well as information. This picture gives you a better idea about electromagnetic waves. See that electric field is perpendicular to the magnetic field, and both of them are in turn perpendicular to the direction of propagation, and this is common with every electromagnetic wave. The electric field, which is changing with time, can be given as E naught, which is the maximum electric field, and it is varying sinusoidally, right? It is given in this way, and the magnetic field is given in this way. B naught is the maximum magnetic field that it can have. See that the angle inside the brackets is same, and omega is the angular frequency, and k is the magnitude of propagation vector, or you can also say it is wave vector. It is 2 pi by lambda. What about speed of propagation? Speed of propagation is given by omega by k, or you can simplify this. Omega can be written as 2 pi by time period, and k from here you can get it as 2 pi by lambda, right? So what did we get? Lambda by time period. In fact, that is true. Lambda is what? Length of one cycle, and time period is the time that it takes to complete one cycle. So you know that speed is equal to distance by time. That's it. So c is equal to lambda by t. You could have started this and you could have gotten this also. Actually, c, which is the speed of light, is given by 1 by root of these two constants, mu naught and epsilon naught, and its exact value is 2.99792458 into 10 power 8 meters per second. This is so exact that this is used to define a meter now. However, let us discuss some features of electromagnetic waves. These waves are self-sustaining oscillations. They regenerate each other, right? They don't need anything else. Just they are enough for them. And no material medium is required for electromagnetic waves to travel. This is unlike the case with transverse waves or longitudinal waves, where you need some material medium. What if a material medium is there? What happens then? Then what happens? The speed just decreases, that's all. Before, the speed was 1 by mu naught epsilon naught in vacuum, right? Because these are the constants associated with vacuum. If you are dealing with some other medium, then the speed in that medium becomes 1 by mu e, where mu and epsilon actually, where mu and epsilon are the permeability and permittivity of that medium. And speed of light in or speed of electromagnetic waves in vacuum is greater than all other mediums. Electromagnetic waves carry energy and momentum because there is electric field, right? And when you have electric field, energy density is given by epsilon naught E square by 2. That means that there is some energy. And even magnetic field energy density is given by P square by 2 mu naught. Hence, there is energy inside the electromagnetic wave, and that comes from the source actually. And this energy can be transmitted. I mean, when sun shines on your hand, you feel warm, right? It means that heat is transferred, that is, energy is transferred. Hence, electromagnetic waves can transfer energy. And what about momentum? Yes, they can transfer momentum also. I mean, they'll exert force or pressure, I should say. That is known as radiation pressure, and you can't feel it. I mean, when sun shines on your hand, actually it exerts some force, but it is so small that you won't be able to feel it. It is somewhere of the order of 10 power minus 8, 10 power minus 9 Newton. Let us solve a small problem. Magnetic field in a plane electromagnetic wave is given by By is equal to 2 into 10 power minus 7 sine 0.5 into 10 cube x plus 1.5 into 10 power 11 t. Unit is Tesla, of course. This is the equation for magnetic field. Then I want to find the wavelength and frequency of the wave. Also, I need to find an expression for electric field E. Let us solve the first part. By is this equation, right? Just now we discussed By in the theory part. We discussed that By can be given as B naught and sine of something. What is that something? 2 pi x by lambda, that is kx plus omega t, right? Or that can be written as 2 pi t by capital T, that is time period. So by comparing this equation with this equation, what can I say? I can say that B naught is 2 into 10 power minus 7, and I can also say that 2 pi by lambda is 0.5 into 10 cube, and I can also say that 2 pi by time period, that is omega is 1.5 into 10 power 11. From this equation I can get lambda, that is wavelength, to be 1.26 centimeters, and this is t, right, time period. From this equation I can get the frequency, which is nothing but 1 by time period, as 23.9 gigahertz. Hope everything is clear till now. We have one more thing to solve. I need to find the electric field, right? Note one thing, there is one relation. E naught is equal to B naught C, where E naught and B naught are the maximum possible electric field and magnetic field inside a electromagnetic wave. So you know the value of B naught, right? It is 2 into 10 power minus 7. So what can you say about E naught? It is 2 into 10 power minus 7 into speed of light, that is 3 into 10 power 8. You got it to be 60 volts per meter, of course. So what is electric field? That will be E naught, that is 60, and sine of the angle will be same, right? So here also you have the same 0.5 into 10 cube x plus 1.5 into 10 power 11 t. So this will be the electric field. And one more thing, B was in y direction, right? And hence from this you can say that the direction of propagation is x. So my electric field should be perpendicular to both. So my electric field will be in z direction. Okay. All the electromagnetic waves can be roughly divided into some groups basing on their frequency or wavelength. And note that this division is only rough, not exact. And you can see that based on wavelengths, they are classified as gamma rays, X rays, infrared. And see this portion. This is the visible light, that is which we can see with our naked eye. And about the visible light, we'll learn more in the next chapter. We'll learn how this light, visible light, reacts when it passes through different mediums and subjected to different conditions. And this classification, this broad classification, is known as electromagnetic spectrum. You don't have to remember this. You don't have to remember this. This is just to give some idea. And hope everything is clear till now. Keep watching. That's it.